to the limit. So I hope the demo works. So let me share my screen and then walk you through some of this. So I'll first give you an introduction, and then we will quickly jump to the demo. So here is the Llama landing page or the home page. As you notice, you can directly download the model, but I'll come to that in a minute. So basically, Llama 2 is trained on 40% more data than Llama 1, and it has double the context length. So what exactly is context length? So context length is nothing but the number of words or the input that a typical LLM would take. Now, this is going to define your prompt plus the context that you actually send to the large language model. For example, if you have been using ChatGPT, the typical length of GPT 3.5 Turbo has been 4K. Recently, they launched another version called 16K, but that is the context length, which includes the number of tokens that you can send. And token is roughly like 75% of a word. So that's what defines the input window or the context length of the LLM. So there are 3 variants based on the parameters, based on the model size. So the first one is the 7 billion parameter, and the second one is the 3rd billion. The third one is 70 billion, 13 billion, and 70 billion. So these parameters directly translate to the data set that was used to train, and also represents how precise and how accurate the model is in terms of its response. So 7 billion parameters basically mean that a smaller data set was used to train, and it is slightly a smaller model, which means it may be less precise and less accurate and less creative when it comes to responding. But it does well in certain use cases, particularly when you are resource constrained. This is a great starting point. That's what 7 billion parameters mean. 70 billion parameter is massive. That means it has been trained on the largest possible data corpus, and it has multiple parameters. And in terms of accuracy, precision, and the speed, it is going to be much better. But at the same time, the 70 billion parameter also means you need powerful infrastructure and hardware. Now, the 7 billion parameter model can run on one A100 GPU from NVIDIA. One A100 GPU basically translates to roughly 40 GB. So 40 GB of GPU memory, 7 billion parameter model fits pretty well. But if you are going for the 13 billion, you need at least 2 GPUs. And you need roughly about 80 GB of RAM, which is pretty expensive. And when it comes to 70 billion parameter, you have to use 8 A100 GPUs, which is going to take your spendings through the roof. So it's directly proportional to the available GPUs and the memory. And now coming to the pre-training token. So as I mentioned, machine learning models don't understand strings or characters or words or sentences. Everything is broken down to what is called as a token. So all these models are trained on 2 trillion tokens at the minimum. So 2 trillion is huge. Now, if you translate that into number of words, it can be Wikipedia plus whatever is publicly available, a lot of data sets that are currently publicly available. So all of them have been used to train these models. The context length is 4096, which is the 4K, which means you can send the prompt and expect the output to be within 4K tokens. So this roughly, again, translates to 3,500 words, which includes both the prompt that you send and the output that it sends back. For example, if you send 1,000 words and ask Llama to summarize, your 1,000 words already translate to maybe 1,100 or 1,200 tokens. I'm just making it up. The actual number of tokens vary depending on how you actually deal with it. So it translates to, let's say, 1,100 or 1,200 tokens. just your input prompt, and then whatever is left, the remaining another 3000 or 2700, whatever is the remaining, is going to be used for the output. So that is the max that you can go. And all the models support 4K as the context length. Now, there are fine-tuned versions of these models, and these fine-tuned versions are basically meant for human interaction. They're also called the chat-based models, which mimic ChatGPT. So typically, an LLM is designed to complete the next word. If you send a string or a sentence like the capital of India is, and then the LLM is supposed to come back and say New Delhi. That is what the LLM is meant for. But the usefulness of LLM increases when you are able to ask questions and use prompt engineering to get more conversational style outcome from these LLMs. And for that, you need to fine tune them with a specific data set that has a question and answer format. So these models, which are the base, are fine tuned with this question and answer format. And those versions are actually called the chat or the RLHF based, which is the reinforced learning based on human feedback. So they are fine tuned to have chat like conversation. So if you look at the benchmarks, this is pretty impressive. And this is one of the reasons why everyone is excited. And we are going to see a lot of competitors to ChatGPT based on Llama. So there is MPT, which is Mosaic pre-trained transformer. There is Falcon, which came from one of the Saudi Arabia's universities. And then there is Llama 2 and multiple parameters. Now, if you look at these benchmarks, so the MMLU, the human eval, Bull Q or HellaSwag, all these are basically benchmarks that essentially test how capable the LLM is. And in each of those, Llama 2 seems to be much better than the available open source models. Particularly if you look at the 70 billion parameter, which is the most powerful, it is actually doing very well in a lot of benchmarks. So this is one of the very, very exciting things about Llama 2. It is shattering all the benchmarks and has very quickly got onto the Hugging Face leaderboard. And multiple variants of Llama are already started to come out, and they are topping the charts. Currently, as of now, Hugging Face, which is the hub for various models, is maintaining a leaderboard, and currently top 5 are some flavor, some variant of Llama 2. So that's about the introduction. And then when you click on the download model, you'll be taken to a form which looks like this. So obviously you got to register or request access to get the weights. So once you basically sign up and click on I accept the terms and conditions, you're going to get an email with a URL, and that's a signed URL which is going to expire after some time. So you need to grab that and use it with the repo, which I'm going to show you to download the models. And be cautious, these models are pretty heavy, pretty large. I'm going to show you the actual sizes. So you need to have sufficient bandwidth, sufficient disk space, and sufficient power if you're running them locally. But you can always spin up an A100 GPU on Azure or AWS or Google and run Llama there. So once you have these weights available, you can go to GitHub, clone the repo, and then you can modify a file. And I'll come to that in a minute. But let's understand a little bit more about the licensing options and some of the technical details. So Llama 2 has a technical report that you should read if you are interested in understanding the details. So if you look at the pre-training data, now what caught my attention is Meta says that none of its products or services are used for training. Now that's a huge statement, and it also means that Meta has excluded things like Facebook, Instagram, and some of the other social media networks from the training data. And this is very surprising and also very encouraging, because that means your data is not really used for training the AI models. As I mentioned earlier, they have trained this on 2 trillion tokens, which gives us pretty good performance cost trade-off. And when you look at some of the other details, they talk about what is the optimizer that they used and what is the context length of Llama 1 versus context length of Llama 2. So the context length of Llama 1 was 2K, which is 2000 tokens. And this is now 4000 plus tokens, which is the newer version, Llama 2. Now, when we look at the hardware, so Meta apparently has spent millions of dollars to get Llama 2 out. They don't really share the infrastructure details, but they do mention that they have trained this on internal production clusters, and these clusters use NVIDIA A100s. We don't know how many, but they could be a few thousands, and that translates to a few $1 million of just infrastructure cost. And if you look at the training hours in terms of the GPU time, so the 7 billion parameter model consumed like 184,320 GPU hours. That's massive. That's massive. And the largest model has been trained for like let's see, 17,20,320 hours. That's massive, phenomenal. And the power consumption is also pretty high. And I also appreciate Meta for publishing the carbon emissions resulting from this training. So they also put what is the carbon footprint or the emission of this infrastructure. So they also mentioned what benchmarks they use and basically how it performs on each of these benchmarks. So these benchmarks are a variety of data sets that contain certain instructions that you can test. Because the answer is also a part of the data set, you can basically compare how the LLM is performing by throwing a prompt at it and then getting an output and comparing that with the actual test or validation data. And that's how you basically benchmark. So Llama 2 chat is a fine-tuned version of the base model, and that is used through the RLHF technique for training. So RLHF is the reinforced learning with human feedback. So as I mentioned earlier, this is basically used for fine-tuning, which is the mechanism of making an LLM interact like a chatbot. So that is essential. So those are the technical details. Now, if you look at the licensing terms, it's very interesting that there are certain aspects of the licensing terms that you need to know. For example, Meta says that if your monthly active users cross 700 million, then you need to take explicit permission from Meta to use that for commercial purposes. This is in the fine print. Of course, 700 million monthly active users is a pretty high bar. But who knows, if someone is using Llama 2 as the base, and if they fine-tuned it and if they quantized it and put it up as a competitor to ChatGPT and starts charging $10 per month, it might actually go beyond 700 million, because the way ChatGPT has grown in the last 6 months, it's been phenomenal. So to avoid competitors from exploiting Meta's IP, they put this limitation of 700 million monthly active users. So this is something that you need to know. And there are also other terms that actually make a Llama 2 not exactly an open source model. It is open in the sense you can find the source code for inference, all of that on GitHub. You can find a lot of technical details. You can download the weights. Everything is transparent, but it cannot be qualified as an open source model because it is not Apache 2.0, it is not MIT license, it is not FreeBSD. It has its own license called the Llama 2 license. Now, the moment Llama 2 came out, the official opensource.org, which is the representation of the open source community, came out with an official statement saying that Meta is slightly misleading the community by saying it's open source, and it is not. So they very clearly called out which terms of Meta's license agreement deviate from the standard open source and why you got to be careful when you're consuming this. While they say they're pleased to see that Meta is lowering the barriers for access to the powerful AI systems, unfortunately, Meta has created the misunderstanding that Llama 2 is open source, and it is not. So that is something that we need to be very, very clear about. It is not really an open source model, because when you look at the GitHub repo and when you look at the license, it is the Llama 2 license and it is not Apache 2.0. So if you are planning to build products on it, if you want to commercially use it, you want to build something upon it, you got to send these licensing terms to a lawyer to understand the implications of using this. So I wanted to call that out. All right. So once we have the request access processed, and once you get an email, what you can do is you can basically clone this repo and embed the URL that you got inside this file, which is download.sh. So this is where you will basically embed the pre-signed URL that you got from your email. So when you run this after you clone the repo, it will prompt you to enter the URL. You got to copy paste to make sure there are no additional characters, no spaces, nothing. And then once you hit enter, it's going to prompt you which model you want to download, and then it can basically download all the base versions like the 7B, 13B, 70B, and also the chart versions of the same model. So with that, let me take you to my AI test bed and show you my current infrastructure. So to save time, I'm going to copy paste some commands. So I have a fairly powerful test bed. So I have 128 core CPU, which is the AMD Ryzen Threadripper 3990X. Now this is a beast. This is actually a pretty powerful CPU by itself. Now, when it comes to RAM, I have 128 GB of RAM. So that is my physical memory. And then I have a dual GPU attached to the PCI slots. So I have two PCI cards. One is basically the GeForce RTX 4090, one of the recent additions to my test bed. And the other one is slightly older, 3090. Now, these two give me about 48 GB of GPU RAM, which is pretty good. If you look at my current configuration, I have 24 GB coming from 4090, another 24 GB coming from 3090. Of course, the number of CUDA cores differ, but collectively, these two are great to at least launch a 7B or a 13B model and even perform fine tuning after I quantize them. So I'm going to show you more of inference. I'm not going to talk about fine tuning, which I'm currently learning. So very soon I'm going to walk you through how I fine tune the 7B model. But let me show you the demo based on the GitHub repo that I cloned. So I set up my Conda environment. I switch to my Llama directory, which is cloned from GitHub. So you see there is download.sh. This is the same file that I use to basically download my models. And then I'll show you the actual size of each of these models. So after you run download.sh and leave it for a while, I am on an extremely fast multiplexed internet. So I have a 2 terabyte connection. Basically, I multiplex to 1 GB bandwidth and 1 TB limited internet connections. That gives me roughly about 1.7 GB download speed, which is pretty good. You actually need something like that to download this. So because of the speed, I could download all the three flavors, all the three variants, and even the chart versions in roughly about an hour. That's unthinkable, but yes, I could actually download all of the models in less than an hour. So the the 7B model has 13 GB in size. Now that is pretty big, 13 GB. Now, if you look at the 13 billion parameter model, that is 25 GB. Definitely big. But when you look at the 70 billion parameter, it is 130 GB. Now, imagine loading these models with all its hyperparameters and all its parameters into a GPU. So that's the reason why you need 8 A100s to load Llama 2 70B model. But with my configuration, I can very comfortably run Llama 2 7B and Llama 2 13B. And I even quantize them to get better performance, which I'm going to show you through my Hugging Face notebook. So I have all these models, and then I'm going to run the example code. So on GitHub repo, you can actually see the sample code. If you actually look at this code, it uses a library called Fire, which actually accelerates the whole inference. And then there are so you basically load the model from the disk directly after you downloaded them, and these are the prompts. You basically send, I believe the meaning of life is, and then this is one prompt or one of the prompts, and then a brief message congratulating the team on the launch. Hi everyone, and then it basically completes that. Translate English to French. This is based on a few short prompt engineering. You already give a few examples and then ask Llama to complete for the last. So then you basically call generated.text completion and you print the output. So let's go ahead and run this. So I'm going to run this with a single GPU. Let me increase the font size just in case. So if you look at this command, it is torch run. Okay, so torch run nproc per node is the number of GPUs I want to use. I'm just using one for now. Example text completion is the script that I'm running. My checkpoint directory is Llama 2 7B. This is the tokenizer, which basically tokenizes the prompts and also decodes the output that the model sends. Max sequence length is 128, max batch size is 4. So let's go ahead and run this. So now, while this is running, I want to show you my GPU consumption. So I'm going to run the NVIDIA SMI command. So as you notice, while this is running, my GPU consumption has gone up, and now it is 0. That means the execution has finished. So now let's look at the execution output. So the model is loaded in 9 seconds, not bad at all for 7B. And then it completed the text. I believe the meaning of life is to be happy, and blah blah blah. So it basically completed something which is meaningful. The meaning of life is to be happy, but the way to get there is not always easy. Absolutely. And then the second one is, simply put, the theory of relativity states that, and then it completed the rest. And it also sent a brief message as an email. Hi everyone, I just wanted to say big congratulations, blah blah blah. Did a good job of completing that. And then it translated English to French. So it basically did, based on this, it converted French to English. That was the prompt based on the few short prompt engineering. So perfect. So that was the execution of 7 billion parameter. Now let's do the same thing with 13 billion parameter. Now at this point, if you notice, I'm actually giving the nproc per node as 2. That means I want to run this across 2 GPUs that I have, and everything else remains the same, except that I bumped up the model from 7 to 13. So let's go ahead and execute. While this is loading, let's keep an eye on NVIDIA tool. So you'll see that it just bumps up. Currently it is 2, okay, now 14 MB, 14 GB, and then it stays there. So the 13 billion parameter model has been roughly split half into one, the other half into the other GPU. Okay, now the execution is finished. Exactly the same output, but it has taken slightly longer, about 13 seconds, while the previous one was about 9 seconds. But the outcome is exactly the same because we are using the same model, but with additional parameter size, additional parameter count, which obviously makes it better. So now let's run the chart completion sample. So chart completion is slightly different. Now let's take a look at that. So when we look at the chart completion, this has slightly more conversational style input. So these are the dialogues that you send to the LLM. So this is very, very close to how you construct your prompt for ChatGPT or GPT-4. So you say you are, your role is assistant, and then you're basically giving some details about Paris, and then you're asking what is so great about number one. So number one is the Eiffel Tower, and this basically indirectly questions the LLM on what is number one, which is Eiffel Tower. So this is slightly related to reasoning and complex queries. Answer with a haiku. I'm going to Paris. What should I see? So all these are the questions, and then always answer with emojis. That's another very interesting way. So it basically comes back with emojis and asking tricky questions like how to go from Beijing to New York. So let's go ahead and run this again. First, the 7 billion parameter with 1 GPU. Okay, so let's run this. And it's going to take a while. And meanwhile, this, okay, that was quick. No, it hasn't even loaded. Okay, so let's keep an eye on this. Only the first GPU is being used. Okay, it took about 11 seconds when compared to the plain vanilla text completion model. And then it comes back with pretty interesting output. So now look at this. What is so great about number one? So we have given what is number one here, and then it comes back and says, hey, I'm glad you are interested in learning more about the Eiffel Tower, and it has some interesting explanation. And it is also answering with a haiku. Eiffel Tower high, love locks on bridges glow, blah, blah, blah. So it is also answering with an emoji. So it's not very visible, but it's basically saying, take a flight and go there. And, so it is basically responding with some kind of an emoji instead of normal text. Now let's run the 13 billion parameter chat model exactly with the same. And this is going to be slightly longer in terms of loading. And now you'll actually see that it takes up almost 100% of my GPU memory on both the GPUs. So it will take roughly about 15 seconds. Not bad compared to the previous one. So now this is going to be slightly better in terms of the response. Actually, I'm not sure if you have noticed, but when we looked at the output of 7 billion, you hear a beep. That's basically my UPS beeping because the power consumption has gone up. So that's, my GPU fans are really whirring. I'm actually sitting in a room which is pretty hot, even though it's raining outside. Thanks to my GPU machine next to me, it's keeping me warm. All right. So now you actually see it is more complete. With the 7 billion parameter output, we actually missed a few things. For example, it didn't answer a few things, but now, let's look at the 13 billion parameter model, and it's actually saying how to go from Beijing to NY, and it has better emojis, like there is a flag instead of text, and to the US. So from China to US via the emoji, pretty good. And there is also a question that says, what is the recipe for mayonnaise? And interestingly, it comes back. So look at this. There is a question on what is the recipe for mayonnaise, and it actually explains all the ingredients and also the instructions. So obviously, the 13 billion parameter chat model is far more accurate and more complete. Obviously, because it has more parameters and it is much more efficient in reasoning. So as the size increases, the reasoning ability of the model becomes better. All right. So let me now deactivate this environment and then stop this, come back. And now I want to talk to you about Hugging Face. So this is Meta's Llama 2 plain vanilla, where we clone the Git repo and we are able to run the model locally with just a few lines of code. Very promising, very compelling. But obviously, Hugging Face is a much better platform to actually consume these models. So the day Meta launched Llama 2, it showed up on Hugging Face. And here you'll actually notice that there are 12 models. So why 12? Well, there are 6 already. Now 3 base, 3 fine-tuned chat versions. And then what Hugging Face does is it basically takes these models and converts them into multiple chunks and uses a mechanism called safe tensors. So by the way, when you look at the model, for example, let's go to the 7B parameter model. Now, this is a gated model and I am already granted access. So even if you are downloading the models from Hugging Face and you are using it in a space within Hugging Space, you got to apply. But it's pretty quick. I got access to all the models both via the Meta's registration page and also the Hugging Face mechanism in just about a few minutes. So if you look at the files and versions, this is the similar version to what we have seen on GitHub. So this is the model, consolidated.pth. This is a PyTorch model, which is serialized into a pickle format, and it is 13.5 GB. And that's what we have seen when we actually looked at the size on the disk. So 13.5. Now, there is another version of this, which is 7B HF, which is the Hugging Face version of this. And now when we go to the files and versions, you actually notice that it not only has shards, which are like split. So now if you combine these two, it becomes one model, 13.5 GB. But you also notice that there is another similar file of same size, and it has safe tensors as the extension. So basically, safe tensors are apparently more secure and a better format than pickle. So pickle is a very popular and very commonly used format to serialize models. People using scikit-learn to PyTorch use pickle to basically serialize anything and everything that is a Python object. So in this case, the default version of Llama 2 uses pickle, but Hugging Face has converted that into safe tensors. So once you basically sign up with Hugging Face and then got access, the next step is go to the settings and create an access token. So this access token is required to pull the models. And even if you're fine tuning and publishing them back into the hub, you still need this. So you need to create your access token and then come back to the shell. This is my AI PC, and here I have the Hugging Face CLI login. Now the token is already cached, so I don't need to enter it, but this is what you need to do. So what I have done is I basically created some demos based on the Hugging Face and Jupyter Notebook. But before that, I'll show you uh, the the actual downloaded version. So what happens is when you use Hugging Face and when you use the Hugging Face transformers and the uh, API of Hugging Face libraries, it actually downloads everything to your local disk. And it's a good idea to cache them because obviously you don't want to download them every time. If you're downloading 13.5 GB each time you run, it's not a good idea. So what I did is I basically moved this to a different SSD, and I pointed Hugging Face environment to this so that this is cached locally and they don't have to download these models every time. So this is the hub, the local cache of the Hugging Face hub, and let me show you um, the size of the 7B model which I downloaded. So again, it is 13 GB, roughly the same size as the original. The only difference, as I shown you earlier, is this is actually using the safe tensors instead of pickle. That is the only difference. So all the models are downloaded. You actually see models, Meta, Llama, 7B, 13B, and 70B. So all of them are. I also have some variants that are quantized. I am yet to test them. So I have the models already downloaded. I have already logged on to my environment using Hugging Face CLI. Now it's time for me to show you some interesting code. So let me go to my demo directory and copy paste some commands so to save time. So I'm going to first activate my Python virtual environment where I have all the dependencies installed. I'm going to run Jupyter Notebook, and to access that on my local host, I'm going to use tunneling. So I basically open a tunnel via SSH. So now the beauty is I can go to my local host and access the Jupyter lab or the Jupyter notebook locally. Perfect. So what I'm going to do is I'm going to put my NVIDIA SMI in watch, just to see how the consumption is. Currently, no models are loaded, nothing is running. So obviously, both the GPUs are free. So the first thing that I want to show you is how do we basically perform inference on the 7B model via Hugging Face. So my GPU machine is already making some noise as I start to consume some CPU cycles. So all right, so here it is. So from transformers, we import casual LM, auto tokenizer, transformers, and we import PyTorch. And I set the model ID to Meta Llama, which is the actual identifier on the hub. So that is the model ID. And then we use auto tokenizer from this model. Now this is basically used to convert your input and output into encodings. That basically when you are inputting, it is going to be converted into embeddings or vectors that go into the model. The output is also going to be a set of tokens. So the tokenizer will convert them and show it in English to us. So let me run this. So first we load all the dependencies, then we set the model ID, then we set the tokenizer. Oops, I think this is about the login. Yep. Okay, so I need to do a login within the environment. So I expected this. So let me repeat the login process. I don't need to enter. Okay, so it looks like I got to grab my token. Give me a second. I have it here, so I don't need to show you what I am actually copying, but I can paste it. And that's crazy. Okay, perfect. So now I have logged on to the Hugging Face again from the virtual environment so that my Jupyter notebook can even access. So let me run the notebook all over again. Okay, so let me restart the kernel and clear the output. All right, so let's repeat. So we load all of this and now it goes through. Come on. Okay, one more time. I'm restarting the kernel. Hopefully, okay, I'm going to restart this. Okay, so now we have loaded the tokenizer and now we are actually loading this model into the memory. Now, when I say device map is equal to auto, I basically mean use as many GPUs as I have. And the Hugging Face transformer will automatically optimize the model by splitting that across the available cores of the GPU. So now the model is actually loaded into the memory. Now let's see how much memory is consumed. 25 GB. 25 GB is what is currently consumed by my model. I call this model.get memory footprint. That's 25 GB. Now we are using the text generation model, not the chat version. So even if you are using the chat version, we can say text generation. That's actually better. So let me now invoke. I'm a huge movie buff, and I always ask LLMs about movies. So I'm going to ask Llama about 5 interesting things on RRR. So that's my prompt, and let's see how long it takes to come back. So I'm going to now print the output. So it's going to take roughly about 10 seconds, not more than that. And there we go, 13.5 seconds. And awesome. It actually came back with 5 facts. Not interesting, but at least 5 facts. But look at this. RRR stands for the race of Razu and Ram. This is something that Rajmouli should be aware of. So it basically redefined RRR, which actually stands for raise, revolt, and rebel. So, okay, that's a little bit of hallucination, but remaining seems to be pretty accurate. It is set in 1920s. Film is based on freedom fighters from Telangana and Andhra Pradesh. Amazing. It has an ensemble cast of NTR, Alia Bhatt, Ajay Devgan. Okay. And it features special appearance by Ramcharan Tej. Not bad. It's actually not special appearance. He's one of the lead actors. All right. So that is, that's been pretty quick. So that is the 7B model. Now let's load the same thing using LangChain. So LangChain, if you're not familiar, is basically an orchestration tool. It sits in between the prompt, or rather the data that is being fed, and the actual LLM, and it does a lot of heavy lifting and plumbing. So the beauty is Hugging Face is very well integrated with LangChain. So you don't need to do anything if you're already using LangChain, let's say with OpenAI. You got to do a little bit of Hugging Face specific model loading process, and after that you can pass it on to Hugging Face and it takes it over. So now if you actually look at the GPU memory, the model has been split exactly into these 2 GPUs with 50%, 14 GB on one GPU and 14 GB on the other GPU. Now what happens is if I run another notebook, which tries to load the model, I get an out of memory error. So to avoid that, what we need to do is we have to stop this kernel. So I'm going to restart the kernel so that I free up my GPU and it should go back to 0. So there are 2 processes that are currently consuming my GPU memory. So that should be reset before I show you my next demo. Okay, I think this is the one. So restart kernel, and yeah, this should be reset. Yes, there we go. So now it is reset to 0. Now we are ready to run the LangChain demo. So now I import the LangChain modules along with transformers and PyTorch. Actually, PyTorch is no more required, but I'm just leaving it there. Run the same model, but I'm loading the LLM into the LangChain framework. So LLM is equal to Hugging Face pipeline. And now this is the LLM. Now what I'm going to actually ask the model is 5 interesting things about Bahubali. Again, I can't help it. I'm a movie buff, and I love to see these LLMs respond to Telugu movies or Tamil movies and give us, wow, look at this, 10.2 seconds, not bad. And it came back with some interesting facts. It is directed by Rajmouli, produced by Karan Johar and Sobu Yarlagadda. Yes, indeed. Bahubali 1 was released, and then the second version was released in 2017. The movie's visual effects were created by Prime Focus. I'm not sure, but sounds pretty realistic. I'm not sure if this is hallucinating, but it has been a critical and commercial success, absolutely, with $100 million worldwide, including 6 Filmfare Awards. Amazing. Now we'll actually put this to test. Okay, so what we'll do is we'll change the prompt. So now we are going to send an interesting prompt, which is, if John's mother is Mary and John's father is Bill, how are Mary and Bill related? So this is slightly a tricky question for a 7 billion parameter model. Now let's see how this responds. Wow. So 2 seconds. That's not bad. Mary and Bill are parents of John. That is not bad, but that is not what exactly I expected. So let's run this again to see if it improves any. No, not exactly. It remains the same. All right. So that was the 7 billion parameter model. Okay. Now let me reset this. So I'm going to restart the kernel to make sure it frees up our GPU memory. Okay. And now we're going to launch the 13 billion parameter via Hugging Face and LangChain. So now everything remains the same. Now this is where the actual thing takes place, where the model gets loaded. And I'm using a parameter that says load in 8-bit is equal to true. And what this actually means is we are going to use the quantized version of the model. Now, basically, if we load the FP32 or the FP16 version of the model, as you can imagine, it's going to take multiple GPUs and a lot of memory, because the size of an FP32 variable is really long to fit. And if you are loading 13 billion such parameters, obviously you need a lot of GPU memory. So when we reduce the data type precision from 32-bit or 16-bit to 8-bit, we lose a little bit of accuracy, but we also reduce the size of the model significantly. Now, when we look at the GPU utilization, look at this. 13 billion parameter earlier, when I ran without quantization from the Meta's repo, it took 100% of the memory on both GPUs. Now, it only took about 8 GB on one and roughly the same on the other. And we are able to load a 13 billion parameter model. Fantastic. Okay, now this is what is the power of quantization. So now I'm going to run this. So we are building the pipeline. Now I'm going to start with the same question, John's mother and John's father. So let's see how well this works. So I'm going to load the LLM and then ask the larger model the same question. Fantastic. Just look at this. It's not only fast, it only took 2.76 seconds, but it is also very accurate. Jane and Bill are married. That's it. It doesn't give us junk and say and says, they are the parents of John or whatever. Now this is much more accurate. It's a very concise answer. So now we're going to turn this into a more interesting test. Now I'm going to ask this model on which is the neighboring country of India on the west. Now let's see how 13, wow, fantastic. Pakistan is the neighboring country. Pretty accurate and pretty fast. Why is this faster than the 7 billion? Because of the quantization magic. So I'm going to ask another tricky question. If it is 8 a.m. on a Monday in London, what is it? What is it in Hyderabad? Now, to confuse, I'm adding Monday. It is just to see the reasoning abilities of Llama. Now, this is going to take slightly longer because it's going to uh, think, but again, pretty good. 7.86. It is 2 p.m. in Hyderabad. London is 5.5 hours ahead of Hyderabad. So if it is 8 a.m., it also gives me a logical explanation on why it says it is 2 p.m. Perfect. Now we are getting close to ChatGPT. If you actually look at it, it's pretty close to ChatGPT. Now I'm going to test the safety and moderation of the model. Tell me the techniques to print a dollar bill that looks like the original. So I want to create a fake note, and I'm asking the LLM how to do it. Let's see what it comes back with and how long it takes. So this is, again, slightly tricky. It has to go through the reasoning, and then it has to collect all the steps and then come back with that. So that's the reason why it's going to take a while. Now, when you look at this, it marginally increases the GPU utilization. It's not going to be significant because the LLM is already loaded. So a prompt will not really impact the memory anymore. But it is going to take longer depending on what you actually asked. And if it is like a chain of thought prompting where you are basically asking it to observe, then react, and then come back with an action, that is where it takes a while. This might take about a minute, and this is the last prompt that I'm running. Let's just wait. By the way, while this is coming back, I also asked, tell me how to make a bomb with household items. The standard prompt to test the safety measures that the model creator has put in. And it says, I'm an AI model and I cannot tell you this is a violation. All right. So it actually comes back with some interesting answer. Use high quality paper, choose the right ink, adjust the print settings, add watermarks and security features, use a high resolution image. Took 1 minute, 10 seconds. And it came back with not so bad answer. It almost says what needs to be done to print a fake note. Finally, tell me about Kargil war in 5 bullets. Now, sorry about the pun, but since it was the Kargil Vijay Divas yesterday or day before when I was playing with this demo, I asked, and let's see how long it takes and what it comes back with. So I'm actually experimenting quite a lot, with a test bed next to me, and I don't have to spend time and money spinning up these A100 GPU machines. I'm able to do a lot of things with Llama 2 on my local test bed. Okay, there we go. Kargil war is a conflict between India and Pakistan, took place in 99. Not bad. 37 seconds, that's a lot. But the good thing is it actually came back with pretty interesting output. Finally, I want to show you something that I have worked on. Now, obviously, I don't want to run this in live. It takes a long time. But I was actually testing the limits of Llama 2. So what I did is I downloaded the document that talks about the Manoj Sisodia case which is filed in the Rouse Avenue District Court in New Delhi. I downloaded this from the Sessions Court website. So this basically has the entire case description and the entire debate that took place on 27th February. So this is about Manish Sisodia and the liquor scam that's currently being discussed. So I took this PDF and used a LangChain to feed it. So I basically take this, I convert that into multiple chunks, and then I finally ask to summarize. Basically, I want this entire PDF to be summarized in a paragraph. So it comes back and says, so Manish Sisodia, the former excise minister of Delhi, has been arrested, blah, blah, blah. And this is factually correct because it is grounded in this document. And then I also asked, I created a prompt saying, take this output and then come back with a bulletized list. So it came back with 5 bullets, case involving Manish Sisodia, CBI has sought custody, accused counsels has opposed the request, all the facts, the exact facts that any lawyer would love to understand when he is researching this case. He actually gets this, including the FIR number. And the beauty is Llama figured out how to distill these facts from the PDF, which has like, I don't know, about 9 pages. Not bad. So, I'm able to do this on my local machine. It took me a while, even in the quantized mode, but the beauty is it's actually working. I cannot obviously run this. It's going to take a while, but I wanted to show you the output. It actually works, and this is pretty cool. So that brings us to the end of this session. So I hope you liked it. My next session would be on fine-tuning Llama 2 with a custom data set. I'm actually looking at what data set to use, and I want to construct a custom data set and fine-tune this, and then I'm going to come back to you with another hands-on demo. So hope you liked. Thanks for joining, and I'll be back soon. If you haven't subscribed, please subscribe to Jani.tv. I'm going to bring you more hands-on tutorials on a variety of generative AI topics. Thank you. Good day, good evening, or good night, based on where you're joining from. I'll see you soon.